So far, 2 chapters in grammar. Only thing which is remaining is L plates on my football shoes.
Shirt, not shoes.
Hello.
Getting confused.
Can everyone please mute themselves? Yeah, try to keep your conversation limited, please. Thank you. So, good afternoon to everyone. We hope everyone is safe and healthy. So, today is our first session, as you all know. And the topic for today is the basics of astronomy. So, before we start, I'd like you to know that this session is being conducted by SEDS VIT, and we are a part of an international chapter that is dedicated to exploring, learning, and most importantly, educating all about space science through our outreach branch. So now, without further ado, let's begin with our session. Ananya, you can take the stage.
Yes. Hello, everyone.
Hello. Hi.
Good evening, ma'am.
Hi.
So is my screen visible?
ma'am.
Can someone please?
Hi.
Yeah, great. So you can keep muted during the session. And if you have any doubts, you can unmute and ask your doubt. Okay, so let's get started. Welcome everyone. SEDS VIT presents a session on basics of astronomy. I am Ananya Ghosh, and along with my friend Anurag Tamane, we will take you through a journey to the solar system and its origin. So today we are going to cover a few topics, and those are origin of the universe.
Ma'am,
Yes.
are you sharing screen, ma'am? If I can't see it. Yes, ma'am.
Yeah, I'm sharing screen. Can you can't see? All right.
I can't too see
Ma'am,
it.
I can't see it.
Ma'am, I can't see it.
Ma'am, it's seeing AG, ma'am.
Okay. Now check if you can see.
No, ma'am.
No, ma'am. Not still.
Just AG.
Ma'am, we can't see.
Ma'am, I think you need to on your camera.
I guess the screen is visible.
Ma'am, I
No,
can't
ma'am.
see
No,
AG.
ma'am.
Ma'am,
I
can't see your screen.
I'm going to share a screen.
I can't see the screen. Ma'am, I can't see your screen. Yes, ma'am.
Okay, just I'll then reconnect.
Yes, ma'am. Now we can. Yes, ma'am. We can see your screen. Ma'am, we can see your screen, ma'am. Ma'am, I can see your screen. Ma'am, I can see your screen.
Yeah, now you can see, right? Yeah.
Yes,
Great.
ma'am.
So
Yes,
let's
ma'am.
start. So before starting with the topic, can you guess some of the planets present on the screen? Just one by one, unmute whichever planet you know.
Yes, ma'am. Earth, Mercury, Venus, Uranus, Neptune. Moon, Earth.
Mars,
Uranus, Jupiter, Uranus, Jupiter.
Okay, which planet is this? This is Mercury, right?
Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune.
Okay, great, amazing. So you guys know very well. All right, so we start with the topic. So there are many planetary systems like ours in the universe, with planets orbiting around a host star. Our planetary system is named the solar system because our sun is named after sol, after the Latin word solis. So sun in Latin is known as solis, and anything related to the sun is known as solar. And the solar system is made up of the sun 8 planets revolving around the sun. This is the Milky Way galaxy. Our solar system is located in the Milky Way galaxy. So the galaxy consists of a lot of planetary systems just like ours. So ours is also located in this Milky Way galaxy. So the solar system consists of the sun, the host star, the planets. There are 8 planets, the dwarf planets. So dwarf planets are something that is not exactly a planet,
Ma'am,
but those are, yes.
ma'am, there are 5 dwarf planets.
Yeah, great. You'll be answering these questions.
Ma'am, can I say one of them?
Yeah, so there are dwarf planets also.
An example.
And Pluto.
Yeah, excellent. Yeah, Pluto is an example. So we'll see the example.
Ma'am,
Ceres is
SEDS
also
is
an
also
example.
one. SEDS.
Yes, yes, absolutely. So there are moons or natural satellites as well in the solar system, along with asteroids, comets, and meteoroids. So the solar system was formed 4.6 billion years ago. So the first 4 planets in the solar system, which are Mercury, Venus, Earth, and Mars, these are composed of rock material, rocks and metals. So these are known as the terrestrial planets. And then there are the 2 gas giants, the Jupiter and the Saturn. So they are made up of hydrogen and helium gas. Then comes the Uranus and Neptune, which are composed of water, ammonia, and methane, and are known as ice giants. So the moons, just like Earth has a moon revolving around it, which we can see at night. So in the similar way, all the planets have moons revolving around them. So those are known as the natural satellites. Then the asteroid belt. The asteroid belt is located in between the orbits of Mars and Jupiter, which is composed of rocks and metals. Then comes the Kuiper's belt. So the Kuiper's belt is located beyond the Neptune's orbit, and it is mainly composed of ice. Then comes the dwarf planets. The dwarf planets are not planets, they are planetary mass, but they do not behave in a way that the planet behaves. These are not true planets. They are smaller than planets. And examples are, as you all said, Pluto, Eris, and Ceres. Then comes the 8 planets: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. You already know these. You have answered. So this is the sun. The sun is the center of the solar system, which radiates light, and due to which we have day, we have light, we can see everything around us on Earth. Then comes Mercury. So Mercury is the smallest planet in the solar system, and it is quite close to the sun. It is closest to the sun. It's the first planet. Then can anyone tell me about Venus?
Ma'am, Venus is the hottest. Venus is the second planet of solar system. Venus is the brightest planet of the Earth.
Yes.
Star and Venus is second planet of solar
Excellent. Yeah.
planet to the sun.
So Venus is the second planet, and it is the brightest object in the Earth's night sky after the moon. And we can even see it with our naked eyes sometimes.
Also a twin planet for Earth.
Yeah, great. So can someone tell me about Earth?
Ma'am,
Can I tell you planet of Ma'am, Earth is the third planet and it's a blue planet.
Yeah, why is it called the blue planet?
Ma'am, it is called the blue planet because
Okay, one by one.
living things there.
All right. One by one can say. So why is it called the blue planet? Yeah, say.
Ma'am,
Why
can
is
I
it
say?
called the... Yeah, sure. Say.
Ma'am, Earth is called a blue planet because 2/3 of the surface is covered in water.
Yeah,
Ma'am,
great.
can one
Three-fourths?
say?
Ma'am, can I say? Ma'am, sugar.
Ma'am, can I?
Okay, so you already know, everyone knows that 3/4 of Earth is covered with water and the rest is land.
Ma'am, Earth is a planet that we live in.
Yeah, excellent. Great.
Life
So
is
this
only
is Mars.
there, ma'am.
Yeah, life exists on Earth. This is Mars.
Ma'am, in Mars there are aliens.
It's known as red planet.
Okay, aliens have not yet been discovered.
Ma'am, Mars is red color, ma'am.
Yeah, so Mars is a red planet. Okay, now let's go to the next planet. This is Jupiter.
Ma'am,
This is Jupiter.
Jupiter.
Okay, you can answer one by one. Answer one by one.
Ma'am, can I also?
Gas giant.
Yeah, it is the gas giant. It's the largest planet.
Ma'am, it has a ring around it, ma'am.
And it has 80 discovered moons.
Ma'am, it has gases.
Yeah, it is composed of hydrogen and helium gas. Great. Then we move to Saturn. Saturn has beautiful rings around it.
Ma'am, yes, ma'am, it has a
Yes.
ring, ma'am.
Ice and
And
dust.
the rings are made of ice, rocks, and dust.
Yes.
Ma'am, Saturn has a ring that's covered of mud and dust.
Yes, exactly. So after that comes, wow, that's really great.
Uranus, ma'am.
Uranus
It is the seventh planet, ma'am.
Yeah, seventh planet from the sun. It is an ice giant. And then comes Neptune.
Neptune. Neptune is the ice giant planet. Planet.
Yeah, it's the eighth planet from the sun.
This planet that cannot, the sunlight is cannot reach it.
It's very cold. It's very cold.
Yes, because it's very far away from the sun. So the sun rays,
Ma'am, Uranus is the coldest planet.
yes, both Uranus and Neptune are very cold because it is far
But
away from the
Neptune
sun.
Ma'am, but Neptune is the windiest planet.
Okay, great. So now we see a video on how the planets actually revolve around the sun. So these circular paths are known as elliptical orbits. So these circular paths are the elliptical orbits around which the planets revolve around the sun. So what is gravity? So gravity is something similar to, have you seen a magnet pulling iron pieces?
Ma'am,
Yeah, you can say.
it pulls everything down, ma'am. If we throw a ball up, it will come down due to gravity.
Exactly, very good. So we see apple falling down from the tree.
Is it gravity now? The Earth we will fly.
Yeah, one by one. One by one.
I'm shook. Ma'am, if gravity is on the Earth, everything will fly up.
So
Ma'am,
Earth is very huge, right?
That's why we can jump higher. On moon, there's less gravity, so we can jump higher.
Yes, exactly. So what happens is, okay, you can mute now. I just explain you what is the theory behind gravity, and then you can ask your questions. So Earth has a huge mass, right? Earth is very huge. So it pulls everything towards itself, and that's the reason why we can walk. We can, the apple falls down. When we throw a ball, it falls down. So it has a huge mass and it pulls everything towards itself. So in the similar way, the sun, which is even more huge than the planets, it pulls everything towards itself due to its huge mass. So the planets revolve in specific orbits around the sun, and they do not get shattered away, or they do not move aside from their path due to that gravitational pull of the sun. Yeah, do you have any questions now?
No question.
Okay, so we move to the heliosphere. So has anyone seen candles glowing like this? Have you
Yes,
observed that the candle,
Yes,
when it
ma'am.
glows, it has an aura around it?
Yes, ma'am, it glows.
Candle needs oxygen to glow.
Yes, candle definitely needs oxygen to glow. That's very correct. But have you observed that there's an aura around the candle?
help us to give our light.
Yeah, exactly. Similar to sun, isn't it? Like the sun gives us light, and that's why we have day.
Yes,
And when
Yes,
sun
ma'am.
sets, there's night. there's darkness. So in the similar way, candle also gives us light, quite similar to sun, right? So have you observed that this candle has some aura around it? Apart from the main glow, there's some aura around it, which spreads. So that is quite similar to what
That's
the
like the sun
heliosphere.
rays. That's like
Yeah,
the
that's
sun
like the
rays.
sun rays.
Even the sun
Exactly.
has it, ma'am.
Yeah, exactly. See this picture? This sun is in here and the aura around it, the sun rays. So these rays are known as, in the space, these are known as solar winds. So it's like a stream of particles coming out from the sun. These are known as the solar winds, and these create a region around the solar system known as the heliosphere. So the heliosphere spreads beyond even Pluto, and it shields the whole solar system from a significant amount of cosmic rays. So anyone knows what is cosmic rays, is hazardous ionization radiations. So these are harmful radiations present around in the space. So the solar system is protected by the heliosphere from these rays. And the scientific study of heliosphere is known as heliophysics, which mainly deals with the space weather, space climate. You have any question?
No, ma'am.
Great. So now we come to the asteroid belt and the comets. So anyone knows anything about the asteroid belts?
Ma'am,
Yes, ma'am.
ma'am, differentiate.
Okay, one by one. Yeah.
The asteroid belts come after, after Mars.
Planets and the gas planets.
Yeah, so it's between Mars and the gas giant Jupiter. There's a belt of rock present.
Ma'am, and the asteroid belt also has series.
To meteorite.
Ceres, yeah. If someone said about Ceres, yeah, Ceres is also an asteroid, but it is quite huge. That's why it is presently, it is known as the dwarf planet presently. So we see
Series asteroid belt.
Okay, so now we go through the formation of asteroid belts. So asteroids look like this, as you can see in the video. Now it is located in between the orbits of Mars and Jupiter. The arrow shows the asteroid belt here, between Mars and Jupiter. This is Ceres, what we're talking about. So now I'll explain the formation of asteroids. So at the beginning of the solar system, so what happened was there was an explosion of a star, okay? And due to that explosion, everything got disrupted. Everything was, disbalanced, and things started moving in a huge motion in circular path. See, slowly, slowly, the gas, dust, rocks, everything started revolving like this in circular motion. And after that, due to gravity, as I explained, everything is pulled by gravity. So slowly, slowly, the things started.
Created, ma'am.
Sorry?
Ma'am, the sun is created, no?
Yes, the sun, moon, everything is created due to this rotational motion and gravity. So gravity clumps the rocks and the soil together and forms small, small planets. And after that, they grow and build more into planets. Yes.
Ma'am, after hole also formed, ma'am.
Sorry?
Was the black hole also formed this way?
Yeah, black hole is a more advanced concept. Maybe in the upcoming sessions, you may come to know about black holes.
A black hole is formed when a star dies.
Can you hear me?
Yeah, so black hole, exactly. Black hole forms when a star dies.
By this process, what happens, ma'am, when the breakdown comes in the solar? What happens?
When there is this explosion, we're talking
What
about the.
will happen if the sun becomes a black hole, ma'am? What will happen if the sun
So
becomes...
as we know, in simple words, as we know that black hole has huge gravitational force, so it will pull everything towards itself.
Yes, ma'am.
So yeah, that is how it may pull everything around it towards itself. due to its whole
Ma'am,
huge
what will
gravitational
happen
force.
after this explosion happens, ma'am?
Only our galaxies made.
Yeah, sorry, can you repeat? Someone was talking about explosion.
Ma'am, what will happen after the explosion comes, ma'am?
You're talking about this explosion that was
Yes,
said
ma'am,
in the
this
video?
explosion.
Yeah. Yeah, so there
Yes.
was a star nearby and it exploded. Okay, so the star exploded, and as stars have huge gravitational force and all, so when it exploded, everything around it got disrupted. So what happens is when you see an explosion, like there's some explosion somewhere on Earth, so what happens around, or volcanic eruption, suppose. So everything around it gets disrupted. There is
Like a
earthquake. There is yeah.
like a volcano evaporated.
Yeah, so when volcano evaporates, that's also a kind of explosion, right? So when explosion takes place, everything around it gets disrupted. Everything around it, gets broken down, shattered, destroyed. So in the similar way, when that star exploded, everything around it was, shattered and exploded. So slowly, slowly, these small particles were formed. Actually, it was broken down into small particles. Yeah, say.
Ma'am, how can a
Ma'am,
star
I was saying that Ma'am, I was
This is a
saying that
theory.
asteroids.
Yeah.
Ma'am, I was saying that asteroids were part of the planet which exploded many years back.
Okay, we'll go one by one.
Okay, listen, children. Listen, guys. So we'll be taking all the questions at the end once Didi is done explaining. Okay, is that fine with everybody? Can we all
Yes,
keep
ma'am.
ourselves on mute for now? At the end, she will
Yes.
answer everybody's questions. Okay. Okay, Ananya, continue.
Yeah. So after the explosion happened, things started revolving in this way, at a high speed in circular motion. So the small particles started clumping together due to gravitational force. So gradually, it formed planets. So it started forming planets and planetesimals. So in the similar way, Mars, Venus, Mercury, all the planets were formed in this way. But what happened was, when there is
Only all planets are formed.
how the planets are formed. So there was this explosion that happened. Now everything started moving at high speed like this. Now all this were composed of rocks, small rocks, ice, dust. So due to gravity, now Mars has gravity, right? So due to gravity, everything started clumping together, coming together, sticking together to each other. And they formed, so small rock particles, if you start sticking together, they form something like this, big rock particles. So these rocks started coming together and formed the planets. And in few places, these rocks could not join together. They failed to join together because there was some imbalance in gravitational force.
Auntie. I have joined now only, Auntie. Hello?
Yeah.
I have joined now only, Auntie. Sorry, Auntie, for being late.
Yeah, no issues. You can just continue
Can
from here. Yeah,
thank
so
you,
we are
Auntie.
going through the solar system. Okay, so
Huh?
now in the orbit between the Jupiter and the Mars, the asteroids started forming over there because the rocks could not join together to form a planet. So they remained small particles like this, and they went on orbiting around the sun just like the planets. So hence formed the asteroid belt. So they could not join together, they exploded, and they formed small rock particles and kept on revolving around the sun in the orbits, in between the orbits of Mars and Jupiter.
Ma'am,
So series you
Jupiter
already,
holds the asteroid belt together from not moving or not going into the sun and hitting the four terrestrial planets.
yeah. So Jupiter is huge in mass and it has gravitational force which holds back these asteroids. So after that, you know already about Ceres. It's a dwarf planet, and you went through the formation of asteroids. So now we come to comets. So do you like Ice creams? How many of you like ice creams?
Yes, me.
Everyone likes ice cream.
I like
ice cream.
Great, amazing. So comets
Ma'am,
actually look like ice creams. Yeah, so comets look like ice creams. So what happens is comets are normal rock particles. Yeah.
the cone is like a trail, ma'am.
Yeah, exactly. In the comets. So, what happens is comets are initially small rocks present in the space. They are revolving around, and the moment they are attracted by the sun, like the sun pulls everything towards itself, right? So, when it is attracted by the gravitational force of the sun, it moves towards the sun. So, this is the rock head of the comet,
Ma'am,
and the gas
is
and
this
dust
the
particles.
comet or is this ice cream, ma'am?
Sorry.
Ma'am, is this image comet or ice cream?
This is an ice cream. So comet looks like an ice cream, right? So I thought you would love seeing an ice cream as well. So
Okay.
yeah, so when the comet, so this is suppose for example, just imagine that this is the comet head and the gas particles and the rock and the dust particles, those form a tail behind, the comet tail. So due to the, when it comes
And the
towards
cone
the sun,
looks like, ma'am,
yeah,
the cone
yeah,
looks like the fire which the cone looks like the fire which the comet leaves behind.
yeah, comet has a tail, right? You know, it has a tail. So
Of
when
fire,
it comes,
of fire.
yeah, like fire. So the fire is basically
Ma'am, I can't
Ma'am,
hear
you
you.
are on mute. Ma'am, you are on mute, ma'am.
I think muted me. Yeah, okay. So can you hear me now?
Yes, ma'am, we can
Yes,
hear
ma'am.
you.
Now we can hear.
So now the comets are composed of ice-coated rock particle, and it is also known as the dirty snowballs. So comets have a orbital period, like it revolves around, and it is like around several years, ranging from like millions years, you know. So you can't see a comet very easily. So now we come to the topic, the history of astronomy. So in earlier culture, the people identified these celestial objects. So whatever objects are there in the space, these are known as the celestial objects. So they thought that these were the gods and the spirits. They did not have the concept of astronomy at that time. So they thought that the gods and the spirits were the celestial objects. And then they you know, please mute yourselves, otherwise it will echo. Yeah. So they related these objects and their movements to the phenomena like rain, drought, seasons, and tides. Then gradually, several evolutions happened, like civilizations and all. So, and the concept of astronomy also grew. Then came the concepts of calendars. So, can you tell me, like, how are today's calendars made? Like, on the basis of what are they made? What calculations are done
Ma'am,
in today's calendars?
months, years. Months and years.
Yeah,
And
months
days.
and years and days. Yeah,
Yes, ma'am.
exactly. So these are calculated on the basis of rotation and revolution of the earth around the sun. So at that time also they calculated the movement of the sun and the moon in the sky because they did not have the concept of earth revolving and rotating. So through that they started making calendars. Then came the concept of homocentric or geocentric spheres centered upon the earth. So what does it mean? We know that the sun is the center of the solar system and everything around it moves, revolves around it. But at older times, it was considered that Earth is at the center and all the planets, including the sun, revolve around the Earth. So, and there is also a concept that the space or the universe is flat. But now we know that it is a sphere. So Plato said that the universe is spherical body. Then came Aristotle.
We can't hear you, ma'am.
Yeah, now can you hear me?
Ma'am, why did
Now
people
we can hear.
consider Pluto as a planet?
So we don't consider Pluto as a planet.
Because
Ma'am,
there are a
Pluto-
lot
Ma'am,
of other
people used
planets
to,
in
ma'am.
Pluto's
Ma'am,
orbit.
why do people used to, ma'am? Why did people used to and now we stop?
So that is a different concept. So we will address it at the end of the session, okay? Because this is a different concept we're talking about. And Pluto is a different concept. So we'll talk about it at the end of the session, okay? So now Aristotle,
Pluto is not found in the solar system, ma'am, nowadays.
Pluto is a part of the solar system, but it is not considered as a planet because the size of Pluto and its behaviors or its properties are a bit different from the planet.
Is that
And it is
Pluto
smaller,
now?
and it is smaller than the planet. Yes, see?
Okay, ma'am.
So it is known as a dwarf planet. Yeah, say.
Yes, ma'am. I know Earth is a sphere, ma'am, but how is the other planets considered as a sphere? Is there a separate research on that, or is that just an assumption, ma'am?
So there has been a lot of research and observations done for so many years. So based on those observations, it has been said that the Earth is also a sphere and rest of the planets are also spheres. So there have been so many explorations done in space, right? So they have sent rockets, they have sent satellites. So those observations have also been done. And through those observations, it has been said that all the planets are spheres. So Plato was a scientist or an astronomer who said that the universe was spherical. And because at earlier times, as I said, it was considered as flat, but then he brought the concept of spherical bodies. Then Aristotle, so this is Aristotle. Aristotle proposed that the universe was made of a complex system of concentric spheres. So which means that concentric means circle inside circle. So in this way, the orbits were there and the planets were spheres revolving in specific orbits. So then various mathematics, various variations in the daylight and length of a day, everything was calculated and various observations were made. So all those observations were also preserved in rocks and cuneiform tablets. So cuneiform tablets are rocks, tablets on which they used to write all their observations and calculations. So in India, Aryabhatta propounded a computational system based on planetary model. So his theory said that the Earth rotates around in its own axis. And the periods of the planets were also given with respect to the sun. So the sun was considered as the center and the Earth revolves and rotates around the sun. So he brought that concept of rotation. And he also told about lunar eclipse and solar eclipse. Then came Bhaskara too. So he was the head of the astronomical observatory at Ujjain. He also calculated the time for the Earth to orbit around the sun. And you know what? The Buddhist university at that ancient times, University of Nalanda, they offered a formal course in astronomical studies. So it was a huge thing. And various people from around the world came to Nalanda University to study astronomy. Then Galileo Galilei constructed a telescope. So has anyone seen telescope?
Yes,
Yes,
ma'am.
ma'am.
Someone
Yes,
told
ma'am.
Yes,
they have
ma'am.
seen
Yes,
telescope.
ma'am.
Yeah,
Ma'am, at
you have
first-
observed the
Ma'am,
space.
And at first, Galileo actually took two lenses and put them a little far away. And when he saw a tree, it was like it was up close. So he put both of those lenses in a tube, and the telescope was invented.
Yeah. So when he discovered the telescope or he invented the telescope, he observed the space from that. He discovered moons of Jupiter. Then came Sir Isaac Newton. He brought the concept of gravitation. So the universal law of gravitation. So this is Galileo Galilei and his telescope. Then came Nicholas Copernicus, who proposed the heliocentric system in which the planets were revolving around the sun. So then he brought the actual concept, the heliocentric concept, that the sun is in the middle and all the planets revolve around the sun. So thank you. Anurag, you can continue with the next part.
I will share the screen now. Is my screen visible?
Yes.
Yes, sir.
Yes.
Okay.
Yes, sir.
So my name is Nurag Tamhane and I'm going to talk about the origin of the universe. Okay. So if you have any questions, you can unmute yourself and ask, but ask them one by one so everybody can get what exactly I'm answering. Okay. Let's begin.
Sir, is it the Big Bang? Sir, is it the Big Bang?
Yeah, we will get to that. That's the thing. Yes, come on. Yeah. Okay. So how many of you have heard of the Big Bang theory?
Mommy,
Sir, I know, sir. I have heard it.
I know, sir.
I have heard of it.
I have heard of it.
Sir, I
Nice.
know,
What
sir.
is Big Bang, sir?
Yes, I will explain that. Okay.
And two,
So
It's a theory, sir.
yes, it's a theory. So what happened is to explain the creation of our universe, many physicists were trying to develop a theory. Okay, so in 1920, a Belgian priest named Georges Lamar came up with a theory that he said like our universe began from a single point. Okay, so he theorized that, and after so many years, a famous astronomer named Edwin Hubble. Have you heard of him, guys? Edwin Hubble.
No, sir.
No, sir.
Yes, sir. He created the Hubble Space Telescope.
He didn't actually create the Hubble Space Telescope. He observed that our universe was expanding. So that's what I'm going to tell you. Like he observed the universe and made observations, and from those observations, he made out that indeed Lamarck was right. That our universe began from a single point and it is expanding into something. It is stretching. So how small was the universe at the beginning? So I would like to say to you, like, imagine the smallest thing you ever seen. Okay, it will be smaller than that. Anything. Imagine, just imagine. It was so small, and just an explosive force was able to create everything that is. Okay, now we are going to see a video, and it's amazing. Okay, let's see. Look at that. From a single point, and bang.
Different galaxies were released.
Yes, over a period of time, our universe is about 13.8 billion years old. So it was amazing. Look at that. How beautiful it is.
Wow.
Okay. Okay. Now we're going to do an experiment. Okay. What do you need for this experiment? Like you can do this at your home in a later time. You need a balloon, okay, preferably white one, and a sketch pen. And I'm going to, through the experiment, you will be able to understand the expanding universe. Okay. So let's see this video. Now, look at this guy. What he's going to do? He's taking a balloon, a simple balloon, and a sketch pen. Okay. Now, what he's going to do with the balloon is he's going to blow in the air, inflate the balloon. Okay. Now, he's going to draw spirals, okay, or dots. You can prefer whichever one of you to draw. Now these spirals or dots can represent planets or galaxies. Okay. And now you have to cover the balloon with the dots or the spirals. Okay. Now he's going to draw them. Now try to draw them with equal distance apart. Okay. There, you might not be accurate with it, but it's fine. But try to cover the whole balloon. Now he will do that. And he'll draw meticulously till everything is filled. Okay. Now what he's going to do is like he's going to deflate the balloon. Okay. Oh, slipped. Now, now observe closely. Like he's going to fill in the balloon with the air. Now the air is the explosive force at the start of the universe. Okay, and observe the spirals on the balloon. Okay, they move away from each other. Now imagine yourself to be on one of those spirals or dots. Observe neatly. Look at that. Are you able to see? Look at that. Did you get it?
Yes.
Yes. So if you like are one of those spirals, so for you, all the other spirals seems to be moving away. So it's like the balloon is the universe, it's expanding, and the spirals are like our Milky Way. It's like our galaxy, and we are in that galaxy. So every other galaxy is like moving away from us. Okay. Isn't this great? You can do this. It's very simple.
So you're telling that there are very less galaxies, or they'll be found.
No, there are many galaxies, but to explain how the universe was created, this observation was made that the uh, expanding universe, everything is moving away from everything. So like if you are on in the Milky Way and if you observe, the other galaxy seems to be moving away from you, but actually the whole universe is expanding. So you see that. Okay.
Yes.
Okay. Now, how many of you know what is a star? Anybody?
The sun is
The sun.
One by one.
It is a raging ball.
Sir, it's a celestial body. Star gives us light, heat. A
Yes,
star,
yes, right. Excellent.
sir, a star is a celestial body which has its own light and heat.
Yes, great. Amazing.
It will have a lot of gravitational force.
Yes, true. It's
When it
what
dies,
keeps us
it
in
will
orbit.
become a black hole.
Okay, look at this. Our sun is also a star sitting in there. It the sun is what keeps us in orbit actually. And look at that red
The
big
sun's
ball.
gravity. Sun's gravity.
Yes, yes. Now the stars are large bright bodies. Okay, so they're mostly made of two elements. Okay, hydrogen and helium. Okay, these two elements and our sun. Okay, inside our sun, 1.3 million Earths could fit in. Yes.
Largest star in the Milky Way galaxy is the UY Scoot.
Can you repeat? Yeah, I think so. Your voice was breaking.
The largest star in the Milky Way galaxy is the UY Scooty.
Yes, yes, yes. Amazing. Yes, true. Now,
Excuse me, sir.
yes,
Sir, can I tell you one fun fact about stars, sir?
yes, yes.
There are more stars in the universe than there are grains of sand on Earth, sir.
Yeah, true. Yes. Now, star formation. Okay.
Stars are made of sodium.
They are made of many elements. Most common of the most of the stars are made of hydrogen and helium. Yes, but you see, at an elder stage of a star, yeah, supposedly. So now star formation. Okay, there are four main stages. Now, to understand these stages clearly, I'm going to relate them with a growth of a tree. So it starts with a seed, then a sapling, then a plant to a tree. Okay, so our stage one is the seed, nebula. So it's a dust cloud, okay, large dust cloud made up of mostly of hydrogen. This is where our stars take birth, okay, nebula, okay. This is our seed. And then after thousands of years, in that dust cloud, there are some dense pockets, okay. They collapse under their own gravity, okay. And now these pockets can be huge. They can be bigger than our solar system, okay. They are huge. Now this becomes the sapling, okay. We are come from a seed to a sapling. Now we come to a scientific phase, the T-Tauri phase. Okay, so after many years, a young star is born. Okay, it's energetic. It is blowing out gases from its poles. Like Earth has poles north and south, so the young star starts developing poles and throws out gases from those. And this becomes our plant, from a sapling to a plant. Now we go to the fourth stage and the longest stage in a star's life, the main sequence star. Our sun is a main sequence star. So after millions of years from the T-Tauri phase, sun goes into the main sequence star. So this is our tree. So the seed to sapling to plant to tree. Did you get it?
So sun is in which phase, sir? Is sun stage 1, stage 2, stage 3?
So our sun is a stage 4. It's a main sequence star.
Okay, sir.
Okay, now look at some pictures. I'm relating the nebulae to a seeds, a protostar to a sapling, and a T-Tauri star to a plant, a main sequence star, our sun, to a tree, a full-grown tree. Now, to get a full picture of how the life cycle of a sun goes or a star goes, we have the nebula, the starting phase. For our sun, it will go from the main sequence to red giant to become a planetary nebula. And it will, at the end of its stage, end of its life, become a white dwarf. It will be smaller than Earth in size, but it will be way heavier, way heavier. It's like a heavy iron ball kind of thing. It will be so smaller in size, but very heavy. But for other stars, it's not the same story, okay? Uh, they go on to become red supergiants. They're big, okay? They're big. As you suggested, the largest star in our Milky Way. It's big. Now, these kind of stars, they explode into a term called a supernova, like a boom, like a big boom. Now, from this stage, there are two stages a star can go to a neutron star. A neutron star in our universe is basically like a lighthouse. Has everybody seen a lighthouse or seen a picture of a lighthouse?
Yes, sir.
Yes,
Yes.
sir.
It emits
I've seen the
light.
lighthouse, sir.
Okay. So a neutron star from its poles emits waves. Okay, so they are like a cosmic lighthouse, or you can imagine them, and they spin so fast you can imagine them to be spinning tops. Have you played with one?
Yes, sir.
Yes, sir. I played.
Yes,
Yeah.
sir.
Yes. So that's how you can imagine. And the
Yes, sir.
next stage, well, the second stage will be a black hole. So black holes are giant vacuum cleaners, okay, in the space. Imagine them to be giant vacuum cleaners in space.
Sir, if you go inside it, the process is called spaghettified.
Yeah, spaghettification. You will be stretched like a spaghetti.
Sir,
Due to
we'll
the
never be able to come out, sir.
yeah, we will be stretched to, and it's like we will be falling for all time for the
Sir.
outside universe.
Sir,
Yes.
but if sun becomes into a black hole, then
There is
our
a
Earth will
wormhole.
also be inside sun, no?
No, for our sun, it will never become a black hole. As I said, it will become a red giant. Then it will go on to become a planetary nebula and into a white dwarf. So our sun will never become a black hole.
Sir,
Okay. Yes.
sir, inside a black hole, it has a very tiny hole that sucks in everything.
Yes. Not even light can escape it. Okay, so let's go forward. Okay, galaxies. So, galaxies contain everything from gases, dust, and billions of stars, and so many of the solar systems. Okay, so on the left hand side, we have an image of the Milky Way. Okay, on the right hand side, we have another image. It's our neighbor. Can anybody guess its name? It's our neighboring galaxy.
Andromeda Galaxy.
Me.
Yes. Yes, brilliant. Nice. Okay, so now we can go to the. Okay, now you have heard about the history of astronomy, right? Now we will go to the
Yes,
future
sir.
of astronomy. What will it be? So, you are able to see the images of the various telescopes, right, on the screen?
Yes.
Yeah. So each one of them have specific tasks. So they observe, they collect information, and then we do research on it and find something new. Okay. Or we find something which we have already known, but little more. Now, what is a telescope? So I know earlier you guys knew about what is a telescope. Now I'm going to give you a story. Okay. So imagine you're planning a trip with your family, okay, to a scenic location. What is the first thing you do? You look at pictures of that place?
No, we will see them with a binocular.
No, no, no. Like you will see the pictures of that place from internet or you will
Yes,
see
sir.
where it is located,
Yes,
right?
sir.
Yeah.
Yes.
Yeah, so you will see where it is located, how does it look. So and then you will wonder like how can I get there by car, by train, by plane. You will figure that out. Then you will say, okay, I have I've been, go, I'm, been, go, I'm going to go there. Now where would I stay? Where would I eat? Where would I sleep? So the picture part, in that your tool is a camera. Okay, your camera becomes your major tool in getting that image of that place, and the image inspires you to go there. Like if you want to go to the Himalayas, when you see the picture of Himalayas, you want to go there, just go there, right? So for
Yes,
an
sir.
astronomer, telescope is an essential tool. They observe everything with it, like the planets, star, and with the help of those they make major observations which are very helpful for us. So basically, they collect information. The more the information you have, the less unpredictable the situations can get. So it helps a lot, helps with our research and everything. So we will get to the main thing, the James Webb Space Telescope. Have you heard of it?
Yes, sir. Yes, sir. We have seen its
Yes.
model.
Yes. So it is going to be launched on October 31st, 2021. It was supposed to be launched in March, but it has been delayed.
Sir, when will the class over? Sir, when will the class over?
What? Can you repeat?
When will the class over?
Oh, yeah, we are at the ending only. Bear with me.
Sir,
Okay.
Okay, sir.
I didn't understand what James Webb Space Telescope is.
Okay, I will explain. Oh, I have a question first. Okay. So we have ground-based telescope, like we have telescopes on the ground, right?
Yes.
But now we are like spending a lot of money and energy and time to build this space telescope and sending them in deep space for observing things like we do on Earth. So why do we do that? Like we can observe the things from Earth also. Why are we spending so much time, money, and everything in building these?
Because that can go in deep space. What we cannot see from telescope also, it can discover other galaxies.
Yeah, like from Earth, you can also see galaxies. But what is the main reason why we do it? Like, why do we have to go to the
We
space
can
and
see vast things.
yeah, and okay, so I'll tell you the main reason is like Earth's atmosphere, like Earth's weather. It is very unpredictable. Okay, sometimes like you feel it's going to be a sunny day and suddenly it rains.
Yes,
Now
sir.
imagine like there is a lunar or solar eclipse and your telescope is ready on the ground. You are ready to watch it, but clouds come in. It's gone. The moment is gone. But from space, there is no atmosphere. There is no weather. So There is no obstacle in between. Okay, so you can observe pictures clearly and very accurately. Get me?
Yes, sir.
Yes, so that's why they are building this, and it is one of the largest space telescopes ever built. It is like the big brother of the Hubble Space Telescope, and well, it is designed and built by NASA with partnership with the Canadian and the European Space Agency. Now it will orbit in deep space about for 1.5 million kilometers away from Earth, and it will be able to see distant galaxies, the coolest stars, and cloud dust, everything. Okay, it will allow us to enable astounding new science. It is going to be great. Do watch the launch though on October 31st, 2021. Now, the square kilometer array. So these are radio telescope. Now you know what is a telescope. Now radio waves. Can some of you tell me what is a radio waves? Or have you heard of those?
Radio waves are signals.
Yeah, like if you have a TV, you get a dish with it, like Tata Sky, Dish TV. You get a dish,
Yes,
right?
sir.
Yeah.
Yes, sir.
So
That's
imagine your
connected in the space, sir. It's connected from the
yeah
space.
satellite. Yes, yes. So imagine you're watching a news. Okay. So from the newsroom, they broadcast the signal to space, and from there to your home. So basically, the information is being sent from the newsroom to your house. So you're able
But,
to get the
sir,
information sitting at home.
they send it to space because from space it can go to the Earth easily
Yes,
together 10 places, or from here, from Earth only till one place.
yes, true. Amazing. Yes, that's the thing. So radio waves are used in communication systems mostly. So the radio in your car, when you hear FM, you switch between different frequencies. On one frequency, you hear a song, on other the news, isn't it? So for uh, the universe also there are so in the earlier stages of the universe to study them, we need radio telescopes. Okay, so these radio telescopes are built over vast lands to gather these radio waves and to extract the information out of them. So the SKA will be built across two continents, more South Africa and Australia. There will be thousands of them, and they will be built such that they can last in a harsh environment. So they will collect data, they will survey the sky like no other radio telescope, and they will collect data which can fill 1 million laptop. It's like filling 2 floors with laptops with full memory. Isn't that amazing?
So that's so much amazing.
What?
It is so much amazing.
Yeah, I know. So, at question time. So, as I said, our universe is vast, right? So, obviously, that begs the question: are there aliens out there? Are there species like us out
Yes,
there?
sir. Yes, sir. NASA found one in the planet.
Yes, sir.
Yes, sir.
Well, you can
Yeah.
think about it.
Yes, sir. Yes, sir.
Yes, sir. We know that.
Yes, sir.
Yes, sir. Yes, sir. Run close to the
Yes, sir. NASA searched one, and there is
Well, yeah, but
another
see,
galaxy.
Yes, sir. NASA.
there can be,
But
yes,
I
true, there
don't
can
think
be.
aliens
Now,
exist.
the second question, okay. So, like we are not always going to be here on Earth. We are not going to live on Earth like forever. So, we need to find Earth-like planets that would sustain life. Now, or the planets
Yes,
which
sir.
could sustain life. So,
Sir, Mars has waters on the poles, so Mars
yes,
might be an option.
yes, Mars might be an option. Yes, correct.
Yes, sir. Mars.
Yes, and
Mars
also in our
option.
Sir,
galaxy,
even
there are many
Proxima
Earth-like planets.
Centauri B is an exoplanet
And
Yes,
discovered
Neptune is
by
also.
yes, exoplanets. Yes.
Sir, Mercury has 5 moons.
Yeah. So these are two amazing questions. Okay, so you think about this and you will find tons and tons of things about these things. Okay. Okay. So thank you, and I hope you enjoy
Sir,
session.
sir.
Yes.
As we are normally in like in a city where that's tornadoes are in Mars.
Tornadoes. Okay. Okay. Yeah. Yeah. Okay. Got it.
So the largest mountain in our solar system
Yes, it's
is
on
in Mars.
Mars. Yes, it's the largest mountain.
Olympus Mons.
Yeah, true. You guys are amazing. Ah, so I hope you enjoyed the session. Okay.
Sir,
Thank you.
on the poles there are waters on the poles. There's ice, and for ice we need water.
Yes, there is ice on the poles of Mars. True. Okay. Okay. So thank you, and I hope you enjoyed the session.
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Thank you so
Bye,
much.
sir. Thank you, sir.
Bye,
Bye,
sir.
sir.
Thank you, sir.
Thank you, sir.
Bye, sir. Thank you, sir.
Thank you.
So thank you,
Thank you,
kids.
sir. Bye,
Also,
sir. Thank you, sir. Bye,
Bye.
sir. Thank you, sir.
if you have any questions that you couldn't ask, you can ask them right now.
Do you guys have any questions? Or well,
If you have any questions, you can ask.
Ma'am, how can a star explode?
okay, so I will answer that question. So what happens is when I said like two elements, hydrogen and helium. So they are like first there is hydrogen, it fuses into helium. Okay. So and the sun has its own gravity. So it's basically a tug of war which is going inside the sun. So at the later stages, the sun is not able to produce much of the higher element. So gravity starts winning. So what happens is after a period of time, the sun collapses in itself. That's how it like kind of explodes. Okay. You get me?
Yes, sir.
Yes.
Thank you, sir. Bye, sir.
Thank you.
Sir, how can we start researching about space from now?
Well, look, for you, like it's oh, Ananya, you want to answer the question?
Yeah, you can go ahead. You can go ahead. If there are any more points, I'll add to yours.
Okay. So basically what you can do for you, like you can, there are many books. Apart from that, you can like search on the internet. There is a vast amount of information available for you.
Sir, but if I want to research by myself without using internet, then
Books or well, now you're in school, so well, you're on a textbooks, but there in your textbooks also there is some of what introduction to astronomy, so you can learn from that. Or well, there are many books, you can find them in the library. You can ask people about books, name of the books. Many authors have written, many great physicists, all of them have written books, and for children also. So you can read those.
thank you, sir. Bye, sir.
Thank you. Hello. So should we end this session now? Or well,
Yeah, wait a second, just wait. Let all of them.
okay. Okay.